Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Technical Campus, Greater Noida. The subject that I teach in this semester is Optoelectronics and Optical Communication. This subject is for BTech 7th semester students of Electronics and Communication Engineering branch. And the topic that I discussed today in this lecture is overall fiber dispersions in single mode fibers and multimode fibers. Dispersion, actually dispersion is one of the form of attenuation, right? Dispersion, attenuation, all these are the losses caused by this optical fiber when signal propagate through it, right? So basically the meaning of dispersion is spreading of the pulse as the pulse travel along the fiber. So what is dispersion? Dispersion spreads the optical pulse as it travel along the fiber. This is the basic definition of dispersion. So dispersion is a phenomena of broadening of the pulse as the pulse travel through the optical fiber. If you concentrate on this picture, in this figure, we have a optical signal containing optical pulses of 10001. Look at this 10001. But there is a tendency of the optical pulses that when they travel along the optical fiber, they are broadening. Not only broadening, they are decay with the distance. The power in the optical pulse decay in the distance. When power is decay, when power is reduced, obviously its voltage and amplitude is reduced because power is because of the voltage and voltage is because of the amplitude. So when power reduced, ultimately its amplitude is also be reduced, right? When this happens at the other end of the optical fiber, where the receiver is to be there to read out the signal that was transmitted by a transmitter, the receiver work on a threshold. If a receiver finds something above threshold, if the receiver find in a particular time duration is above threshold, receiver declared 1 is received. And if receiver finds something in a particular time slot below threshold, receiver declared 0 is received, right? So on the basis of threshold, receiver works. So what happens when these 10001 optical pulses that contain information reach to the through this optical fiber reach to the receiver side, and because the power is reduced in this signal, their amplitude is also decreased, and sometimes these amplitudes of 1 come to below threshold, and instead of reading 1, receiver declared as 0 because receiver work on threshold. So that error come in the picture, and that error is because of dispersion. So this is one of the case when the signal or the optical pulses is to be travel across the optical fiber, their power reduced, their voltage reduced, and their amplitudes are also reduced, and the receiver may gives the error. Error in digital communication or optical communication means when receiver is able to read 1 instead of 0 and 0 instead of 1. This is the only two possibilities of the error that come in the digital type of optical communication. Another thing, if you say in this picture, this is in this particular thing, dispersion also causes spread of the pulses. So when the pulses are spread as they travel across this optical fiber, what happens? Every pulse, whether it represent 1 or 0, have a certain time slot, and when the pulse broaden, actually it crosses its time period and reach to the neighbor pulse. So this is called overlapping of the pulse. So how this overlapping come in the picture? When the particular pulse having a certain time slot. Because of the broadening, because of the dispersion, they, the particular pulse, because of the broadening, reach to the neighbor pulse. So that creates a overlapping to the neighbor pulse, and this is called this is one of the form of dispersion, broadening of the pulse. So what happens because of this broadening of the pulse? When this overlap pulse reach to the receiver side, receiver is confused to read 1 or 0 correctly because of the pulses are overlapped. So receiver may give you a wrong reading. Instead of 1, receiver may declare 0, or instead of 0 may declare 1. So this is another possibility. So these are the two cases. This is the form, dispersion in the form of attenuation, and we have discussed two cases: reduced power case and spread the pulse, right? So what is dispersion? Dispersion spreads the optical pulse as it travels along the fiber. And this spreading of the signal pulse reduces the system bandwidth or the information carrying capacity of the fiber. Another, another, another thing, another concept is that is also be proved that because of the dispersion, because of the spreading of the pulse, it reduces the system bandwidth, and because of that, information carrying capacity also of the fiber is also be reduced. So, last point is an error occurs when the receiver is unable to distinguish between input pulses caused by the spreading of the each pulse. Each pulse that we already discussed. Okay, what is the possibility of error? So, the effect of attenuation and dispersion increases as the pulse travels along the length of the fiber as shown in the below figure. So in this particular picture, what we shows that as the input pulse is to be travel along the optical fiber, inside the optical fiber, it broaden when it is spread, and because of that overlapping come in the picture. Look at this picture. Is a distance travel, it's the input pulse, and look at this input pulse. After reach inside the optical fiber, after a certain distance, look at this output pulse. Look at the output pulse. So, in addition to the fiber attenuation and dispersion, other optical fiber properties affect system performances. Fiber properties such as modal noise, pulse broadening, and polarization that we will discuss in the next lectures about these terms, polarization, and that also reduce the system performance. So, along with this dispersion and attenuation, we have other factors that are responsible for the loss of a signal. We will discuss these particular things in next lecture. Again, we have a dispersion. Look at this picture. So, there are two different types of dispersion in optical fibers. One is intramodal dispersion, another is intermodal dispersion. Look at the intramodal. This is intramodal, this is intermodal. Two types of dispersion are there in optical communication, in optical fiber. Intramodal, also called as chromatic dispersion. Look at this, intramodal, also called as chromatic dispersion. This occur in all types of fibers. Means intramodal, or you may say second name is chromatic dispersion, occur in all types of fiber. When I say all types, mean all types single mode and multimode, both are covered in this intramodal or chromatic dispersion. Another is intermodal or modal dispersion, occur only in multimode fiber. But intermodal dispersion, which we also called as modal dispersion, occur only in multimode fibers. So each type of dispersion mechanism lead to pulse spreading. This is the basic definition of dispersion, pulse spreading. So this happens as the pulse spreads, energy is overlapped. This we also seen in this particular picture that these are overlapped. The two pulses are overlapped, and this is the case of, and this is due to the pulse spreading, and this whole phenomena is dispersion. So the spreading of the optical pulse as it travel along the fiber limits the information capacity of the fiber. We already discussed this point in previous slides. Come to intermodal or modal dispersion occur because each mode travel a different distance over the same time span. Try to understand this intermodal dispersion, and this happens only in multimode. Multimode, we have thousands or hundreds of modes are possible. Each mode travel a different distance. When each mode travel a different distance, and we also know that the speed of the all modes are same, and they travel different distance because uh, this may possible to cover a particular distance, particular ray or a wave may have two zigzag paths to cover the whole distance, and there is also a possibility that another mode have, for example, 10 zigzag path to cover the same distance. So when the wave or a signal have many zigzag direction, then obviously this particular case, in this case, the wave travel more distance, isn't it? As compared to the wave that have only one or two zigzag directions. So this is clear that several modes may be possible because intermodal or modal dispersion uh, only happens in multimode fiber where many modes are possible. Each mode travel different distance with the same speed. The meaning is that they all mode because of the same velocity and different distances appear at another end of the optical fiber in different time. So there is a time difference. There is a time difference. Time to come at other end of the optical fiber. There is a time difference of all the modes. And what is the reason behind that? Because they have same velocity, but the distance are different. So their arrival times are also different at other end of the optical fiber. And that is called intermodal or modal dispersion. Thank you very much.